Thank you for reviewing the theory, the modified theory, including the V-shaped track for the loop-the-loop. We've seen that with a smaller ball, the height above the bottom of the track increases because of a difference in rotational kinetic energy caused by the smaller radius with 2 points of contact for the smaller ball when it sits inside of the track. Notice that the larger ball effectively sits on top of the track, and that's the theory that is explained in the appendix. The smaller ball, this one of 2 centimeter diameter, and this one of 1 centimeter diameter, they do sit inside the track. And you might note that the theory is independent of the size of the ball so long as it sits inside the track. So let's release this smaller ball at a considerably higher height and see if it can make it around the loop from a higher height than the larger ball. It did make it around almost, so I will release this ball at the very highest point of the track and see if it makes it around, and it successfully did make it around. So this verifies the fact that there is a difference between a ball sitting on the outside of the track or a ball sitting on a flat track and a ball sitting inside of the V-shaped track with 2 points of contact instead of 1. This theory has been modified so that theoretically a ball sitting inside the track should be able to be released at or slightly above 2.9 times the radius of the track above the track, which is the red mark. However, you noticed that this ball had to be released at the very highest point up here in order for it to successfully make it around the track. So you see, there's even more trouble on the loop-the-loop. What is this trouble? I believe it comes from 2 things. One is the acoustic noise created as this ball traverses the track, considerable amount of noise, considerable amount of energy loss. And the second thing is that when a ball travels down the track, it does suffer air resistance. We study air resistance in our classrooms with Stokes drag as a ball falls freely through the air. It has nice, smooth, laminar flow around it. However, as the ball inside the track travels down the track, the V-shaped track influences the flow patterns of the air, probably causing turbulence, drastically increasing the air resistance. And I think those 2 factors can account for the fact that the ball must be released considerably higher than the predicted values, even with the new modification of a V-shaped track. And as I say, there's even more trouble on the loop-the-loop. Thank you.